So, if you've been following along on this brown 1983 Ford F-250, you would know that in the second episode, when we went underneath the truck, we found a banana drive shaft, a destroyed drive shaft. The whole back end of this drive shaft looked like someone stabbed a forklift through it. It wasn't good. It's this drive shaft right here. As you can see, it's no longer as straight as it should be, and it's pretty toasted. I have a remedy for that though. You shall not pass. What I got here is basically a cannibalized drive shaft that I have in the back corner of the shop here. I make my own drive shafts here for all my squirrely hot rods, and this one's going to be no different. Basically, I'm going to be cannibalizing the tube off of this shaft. This is actually off of the 1996 Ford F-150 with the 460 big block. Back when it was a four-wheel drive automatic E4OD truck, and this was off the transfer case to the 8-foot bed. The only thing is, we can't do this here. So, with the snap of my fingers, here we are. We're in the weld shop, there at work, after hours. It's the same spot that you saw the 1992 Mazda getting torn apart. That was a fun time. So yeah, this is basically me showing you guys how to build a DIY home drive shaft. As long as you got two yokes and a tube, you should be okay. So yeah, let's get at it and let's save some money. Alright, so the very first thing that we want to do in this case is we want to measure our drive shaft tube, basically from weld to weld. You can measure also from centerline cap to centerline cap. That's an even better idea. So we're going to do that, and let's just see what it roughly is. Roughly 36 inches. So we're going to write down on our table 36 inches, and that's center of cap. Let's not write it like that. Center of cap. Now we're going to measure out from our weld to our weld, and we're going to account for a little bit of slop since it's a, banana. So we're looking at roughly 32 and 5/8, and that's weld to weld. So 32 inches and 5/8, and that's weld to weld. Now, what I'm going to do personally, we have a little button on the bottom. That was made from factory, most likely to balance the drive shaft. So we're going to zing it off there, and then we're going to measure 32 and 5/8 down the shaft, and we're going to cut it on both sides so we basically have a nice tube to work with. Now again, just so you know what I mean, all we're going to do, we're going to cut about there, whatever. Now what we're going to do is, again, we're going to measure off our flange, and we're going to go over to 32. Oh, stay down now. Don't you go anywhere. I still need you. So we're going to go, and we're going to measure out 32 and a half, and then 32 and 5/8. We're going to go just a little bit more, just in case. And there we go. That's 32 and 5/8 right there. So we're going to cut that now, and then we're going to have a good tube to use for our drive shaft rebuild. We got our tube, 32 and 5/8. We're going to leave that for right now. What we have to focus on now, fellers, is we're basically going to take an angle grinder, 4.5, 5-inch, whatever, and we're going to gouge out these welds. And once they're gouged out enough, these caps will literally just pop right off. It's quite nice. So I'm going to set this up here, basically clamp it to the table. You can't hurt this pipe anymore. Nothing that you can do to hurt that. And we're going to basically start cutting. So time lapse, baby. Jumpy. So we went a little bit rambunctious on this one, as you can see, but that's okay. We'll just fill that up with weld and grind it down. So now what we're going to do, we're going to do the exact same thing to the other side. We're going to cut that free, and then we're going to come right back. Give me a second. Now, more often than not, the tubes that Ford uses have a seam inside them. I don't know if you can see that. Focus, there we go. They all have a seam inside them. The caps don't fit with the seam in there. So all what you have to do, just take like a die grinder with a carbide. You can get them really cheap. But if you don't have one, use a rat tail file or something like that. Even sandpaper would work after a long enough time. And you basically want to take those down far enough that it will butt up against its flange. So about 1/2 inch, 3/4 inch in. And sometimes you got to do a couple rotations around just to hollow out the pipe a little bit. So I'm going to do that. And basically then we're just going to press these in. And we should be all set. Alright, so now, I already put that one in at the end. I'm going to show you guys how to do this one. You want them to be basically as snug of a fit as you possibly can get. So, with the old U-joints inside them, you want these yokes to have the old U-joints in them because you're going to be hitting the ears, and without them you'll collapse the ears, but with the caps they'll have a good chance of surviving. So basically what you're going to do is you're going to put this on the ground, smack it, whatever, and you're just going to try to get it started. Once it's started, you can work with it. But the main thing that you want to do is you want to make sure that you're phasing your yokes to the other yoke. What I mean is simply this. If the top of this yoke is pointed straight up, the top of this yoke is also going to be pointed straight up. You can tweak it as you go with the hammer, but if you put it in that way, you won't be able to rotate that on its own axis while it's inside the tube. It just won't happen. Basically, what I'm going to be doing now is you find the flattest cap and you rock it. And you basically want to rock it until there's no rock no more. And you want to adjust these so it's completely flat. That's why we're on a welding table. But any flat, non-bendy surface will work. So basically, with that one stationary, you're going to work this one until all your rock is virtually gone. See what I mean? We've hit this basically and worked it, and as you can see, there's not that much rock left, but this is still way too much. You would feel this inside your truck. So we're going to keep knocking this forward, and then we're going to line them up completely. So I'm going to keep doing that, and yeah, let's keep adjusting this. So again, what I'm talking about here, we got this pretty much squared up. It's not very bad at all. There's hardly any rock inside it. Pretty much all squared up. We're going to move it over to the welder and start welding it up. Alright, so what I did so far is I did 2 hot passes on it. We're dividing this drive shaft up into 4 quadrants on each side, and we're welding 1 quadrant at a time. That way it kind of, and we're doing opposing quadrants, so there would be like 1 and 3 and 2 and 4. Basically to avoid warpage on this shaft at the end of the day. So we're going to finish up the other 2 quadrants, and then we're going to clean it up. So yeah, let's get at it. Well, there you go, fellas. Both caps are on, nice and solid. I even cleaned up the tube a little bit with the wire wheel. Does it look showroom? No, not really. But that's what you get for using used parts. But this drive shaft is going to be plenty strong for what we're doing. It measures out to spec. Now all what's left is paint. Oh, you guys are still here. Well, all I'm doing right now is just finishing up, adding a little bit of coated black to this, make it look showroom sharp. I hope you guys enjoyed this video. I hope you guys learned something. I'm not saying it's the right way to do things, but it's worked out great for me in the past so far. There's only a few more videos for this brown F-250 up on the chopping block. And then, hopefully, you know, it's going to be out on the road. I'll see you guys in the next episode of Hi-Ho Stable Garage. Alright, I'll catch you later.